Elementary Statistics, Practice Test number 5, Module 5 covering chapters 10, 11, and 12. Chapter 10, Correlation and Regressions. Chapter 11, Goodness of Fit and Contingency Tables. Chapter 12, ANOVA, Analysis of Variance. We're going to cover Chapter 10, Correlation and Regression. Number 1, given the sample data, find the value of a linear correlation or test the claim that there is a linear correlation between the two variables x and y. Use both methods. Alpha is 0.05. Find the regression equation. Find the best predicted value of y when x is equal to 2. So let's discuss correlation for a minute. Scatter plot and the strength of linear correlation are. A scatter plot is a graph of the ordered pairs x and y. X is the independent variable, y is the dependent variable. So we look at the trend here. Distinct straight line or linear pattern, we say that there is a positive linear correlation between x and y, since as the x increases, so does y. Same thing, but this time negative slope. Distinct straight line or linear pattern, we say that there is a negative linear correlation between x and y, since as the x value increases, the y value decreases. There is no clear pattern, no distinct pattern, which suggests that there is no correlation between x and y. If there is a strong positive linear relationship between the variables, the value of r will be close to 1, normally 0.7 or larger. If there is a strong negative linear relationship, this time the value will be close to -1, like negative 0.7 or smaller. Correlation does not imply causation or causality. So going back to the question, let's find part A, or the linear correlation. Normally this is done by technology, but I've chosen a small sample so we can do this by hand in case. We look at the formula. R is n summation of xy minus summation of x times summation of y, square root of n summation of x squared minus summation of x quantity squared times n summation of y squared minus summation of y quantity squared. There are other types of formulas they use. Ultimately, it means the same thing. And I hope you see it's a pretty complicated formula. That's why it's done by technology. However, if we were to do this by hand, we have this x column, we have this y column. Now, when we look at this one, we want x times y. So we're going to multiply this column by this column. So 1 times 2 is 2, 1 times 8 is 8, so on and so forth. We also need summation of x times summation of y. It's coming up in a moment. We also need summation of x squared. We also need summation of y squared. So what is x squared? The first column, square it. 1 squared, 1 squared, 3 squared. We need the second column squared. 2 squared is 4, 8 squared is 64, so on and so forth. Now we're going to add them up, each column. So summation of x, add this column up, summation of y, we have all of this. Now that this table is complete, we plug in. So how do we plug in? We want n, 1, 2, 3, 4 pieces of data, times summation of x times y, we have it here, minus summation of x, which is 10, times summation of y, which is 20. So that takes care of the numerator. We do the same thing for the denominator. We pay attention to n, again, is 4. Summation of x squared is 36. And you can look at the rest. Plug in, again, this table, and all the sums will help us get to r. We come up with negative 0.135. Again, This is not done by hand, but if we were to do this for a small sample like this, it is doable. So we continue. How do we use the technology? I have the TI command for you here, plug in the information into two lists, L1 and L2. Notice L1 is X and L2 is Y. By the way, if you interchange them, the correlation becomes the same thing. I want you to know that. And it gives you the information how to put it in. You run the regression analysis, linear regression t-test. As you can see, the X1 list is L1, Y1 list is L2 already. Don't change that. Do the calculation. It does give you a lot of information. For this part, we only need R. But we have a lot more information here. We're going to discuss it shortly. So the R is calculated, needless to say. It has a lot more decimals here. Also, if you look at all this stuff that I put for calculators, this is one of those calculators that you may want to use. It's pretty easy to use online and it's free. Let's do the test of hypothesis. The null and alternative hypothesis, as always, we start with that. H0 rho equals 0. H1 rho is not equal to 0. Two-tailed test claim. This is the correlation which we use the Greek letter rho instead of R, which goes for the sample. So rho equals 0. That means there is no correlation. Rho is not equal to 0, which is a two-tailed test, and that's a claim. That means there is a correlation. This is the way the null and alternative hypotheses are set up. The next one is to calculate the test statistic. There are two methods. By the way, this mu sub r, that means rho. Mu sub r is equal to rho, comes from H0, and it's always 0 for us. Sometimes you see this formula. I want you to take a look at both formulas. It depends on the text, and degrees of freedom is n minus 2. Let's plug in. Basically, all you have to do is just plug in the value of R, which was calculated in the previous page. Obviously, n was 4, so 4 minus 2, do the math. This is the test statistic if we use the first method, which uses the t-test. For the second method, just the value of R is considered to be the test statistic. What about the critical value? And RR rejection region, NRR non-rejection region. It is always a good idea to come up with that and do the graph. So it's a t-test, alpha is 0.05, degrees of freedom is n minus 2 equals 2. From the t-table, we get plus minus 4.303. I will remind you how to get that on the next page. As for the second methodology, we already have the test statistic. The critical value comes from a table, the Pearson correlation coefficient table. And n equals 4, alpha equals 0.05. Critical value is plus minus 0.950. Again, I will show you the next page. Let's do the drawing. This is the drawing for the t-test. The information for the first method is here. You have plus minus 4.303. Those are the critical values. And the value of R, which was calculated for the test statistic, is right here in between, way into the non-rejection region. The second method, you really have a number line. That's all you have, a number line. Critical value is negative and positive 0.950. The value of test statistic, negative 0.135. It's in a non-rejection region. Your decision is fail to reject H0 or do not reject H0. So again, we want to pay attention to part A for now only, and we go back to this. If we don't reject H0, we are rejecting H1, we are rejecting the claim, and therefore there is no correlation between the two. So I repeat, this means there is no correlation, this means there is a correlation. Since we do not reject H0, there is no correlation. As far as the table is concerned, here's the T table. We need the degrees of freedom on the left side. We are looking for degrees of freedom is 2. And alpha is 0.05. So we need the total area in two tails to be 0.05. So we're going to put those two together. And that gives us this number. And it's a two-tailed test plus minus 4.303. As far as the next one is concerned, Peerless correlation coefficient table. Again, we have all of this table posted. N equals 4, alpha is 0.05. So n equals 4, you look for this number. Alpha is 0.05. So n is 4, alpha is 0.05. Put them together, you have the answer. And because it's 0.950, you put plus minus since it's a two-tailed test. What I want to add, in some text, even with the Pearson correlation coefficient, they don't use n, they use degrees of freedom. So you have to subtract 2. So what is the degrees of freedom? When n is 4, it's 2. So they may give you df instead of n. Be careful with that. Let's do the regression equation. Again, since we had this worked out, I want to discuss the formulas that are complicated, yet everything is done by technology. Remember that. But quickly, how does it work? In essence, you're looking for the equation y equals mx plus b, where m is the slope and b is the y-intercept. The methodology for regression, we use y hat or y prime, and we use b sub 0 plus b1x or a plus bx. This is the one that is normally used in technologies such as TI. So pay attention to the lettering that is being used. So let's calculate a b sub 1. Take a look at all of this. We had it calculated in the first place, so we have it. We plug in, for example, n. We know it's 4. Summation of xy, we know it's 48. Minus summation of x, which is 10 times summation of y, which is 20. The denominator is n summation of x squared, so 4 times summation of x squared is 36. Minus summation of x quantity squared, summation of x is 10, so 10 squared. You do the math, this is the answer. As for the y-intercept, b sub 0 is y bar minus b1 x bar. Y bar, that means summation of y, we already have it, divided by n. You basically get the mean for the y. You get the mean for the x, the summation divided by n. And now plug it into this formula, which means y bar, which is 5, minus b sub 1, which is negative 0.182, but I'm using more decimals here, times x bar, which is 2.5, resulting in number 5.455, and we write this equation. So take a look at this. Calculator, when we ran linear regression t-test, gave us the value of a and b, and this is what I mean. We go with a plus bx for ti. We put it in. The next one is we want to calculate the best predicted value, and the best predicted value for any value is y bar when there is no correlation. We prove there is no significant linear correlation. The best predicted y value is always y bar, and y bar was calculated as 5. So again, we came up with the answer that there is no correlation. We're going to look at a similar question. A researcher is studying the effects of testosterone injection on different lab mice. She controls the concentration of testosterone injected into the mice and measures their metabolic rates. Analyze the following data. Here's the given data. Say, will you be running a correlation or regression? And we want to find the value of a linear correlation, so on and so forth. So first and foremost, we are going to look at the correlation. The reason why, because we are controlling the situation. We are not just observing. So she controls the concentration of testosterone injected into the mice and measures their metabolic rates. That's why we do the regression analysis. Again, nobody expects you to do this by hand. What happens, we start with H0 and H1. H0 row is 0. HA or H1. Sometimes we use H1, sometimes we use HA, alternative hypothesis. Rho is not zero, and it's a two-tailed test. Now, what does it mean when rho is zero? There is no correlation between the concentration of testosterone in mice and their metabolic rates. Otherwise, there is, and this is the claim. So you really have to write this sentence. This is extremely important as you do the math. So the very first thing is to calculate a few things. We are going to use a technology. The technology gives us, in this case, we use Excel, the value of R squared, and this table. I'm going to discuss this table and what each piece means in a moment, but we run it either with TI or Excel or any other calculator, including the ones that are online. We have the table. Let's continue with the process, see what we end up with. So the very first step, we have H0 and HA. Now, the test statistic, let's go with the formula. And again, I'm going to emphasize this mu sub R. Sometimes they just don't put it because it goes to zero. If you calculate this, you end up with this number, which is this one. For method 2, R was given. So for method 2, we use R. For method 1, we can use the R and calculate this. Or as I said, when you ran the technology, this was given to you. T-stat, it says at top. So that's test statistic. The next one is based on the t-test and the p-value, because the technology gives you the p-value. Look at this one. And remember, this means times 10 to the power of negative 15. That's the meaning of E. It's the exponential. So times 10 to the power of negative 15 makes it extremely small. So this is the p-value. We are going to reject H0. Why is that? The p-value is way smaller than alpha of 0.05. In science, normally, such as social sciences, we use 0.05 as alpha unless otherwise mentioned. So you're rejecting H0. So let's go back. If we are rejecting H0, that means we are okay with HA, and the claim becomes true. There is a significant linear correlation between the two variables. Basically, you write this one now as the next part. Therefore, we conclude that there is a significant correlation between the concentration of testosterone in mice and their metabolic rates. Since this is a regression study, the significant slope suggests that the increase in concentration of testosterone in mice causes increase in their metabolic rates. We're going to continue and go with the regression equation. Again, bear in mind, technology has given us this table. So what is the equation of a regression line? I write it. Where does it come from? Take a look at those pieces of information. The intercept. And this is the coefficient you use as A. So coefficients gives you the equation of a regression line. Technology gives us the information this way. The next part, we want to find the best predicted value of Y, which is the metabolic rates when X is given as 1.3. So that means we're going to plug in. The reason we are going to plug in, because we proved there is a significant linear correlation. We are going to plug in, we're going to replace the X with 1.3, come up with the answer, 638.2697. And the last part, using the above pairs and the value of R, what proportion of the variation in metabolic rates can be explained by the variation in the concentration of testosterone? It is always the value which is R squared. R squared is given to us. We are going to change this to a percentage, and we're going to claim it's 98.69%.